In this video, we're going to take a look at exam revision for one-step equations. So all we're going to do here is just take a look at some exam-style questions for solving one-step equations. As always, what I would say is pause the video, have a look at the questions as they appear, and double-check that your solution matches what we get on the screen. That's everything that we need here to get started. Let's begin here with question 1. Let's start with the first part here. So we're asked to solve the following equations. So I've got y minus 4 equals 5. So just remember, to solve one-step equations here, we just use inverse operations. What we're looking to do here is solve for y. I need to get rid of this minus 4 here on the left-hand side. So using inverse operations here, what we're going to do is we're going to add 4 to both sides. Okay, so add 4 to both sides here. On the left-hand side, we get y minus 4. So if we add 4 to that, minus 4 plus 4, that would give us 0. So we just get left with y. And on the right-hand side here, we get 5 plus 4. If we evaluate this addition here, then we find that y is equal to 9. Okay? That would be the solution there to the first part there, part A. Moving on to B now. We've got y over 2 equals 6. If we just think about what we're doing to y here for a moment, we're dividing y by 2. So using inverse operations here, what we need to do now is times both sides here by 2. Because the opposite of dividing by 2 here is to times by 2. So times both sides by 2 here. If I got y over 2 and I times that by 2 here, that would just leave us with the numerator. So that would just leave us with y. And on the right hand side here, 6 times 2. We get 6 times 2, and if we just evaluate that multiplication there, then we find that y is equal to 12. Okay? And again, you can always double check your solutions here. If we're saying that y is equal to 12, 12 divided by 2 would give us 6. So we can see then that the solution there is correct. So let's move on to the very last one here, C. We've got that a equals 4y. And this one might look a little bit different because the variable that we're looking to solve for here is now on the right hand side, but this doesn't change anything. So what we're doing here is we're taking the variable y and we're timesing it by 4. So we'll just use inverse operations here. What's the opposite of timesing by 4? Well, that would be to divide by 4. And whatever we do to one side here, make sure we do it to the other side as well. We divide both sides by 4 here. So 8 divided by 4 would give us 2. And 4y divided by 4, that would just leave us with y. And if we just write the variable here on the left-hand side like we traditionally do here and here, in that case we can see that y is equal to 2. Okay? And there we have it. So that's the solution to C. And that gives us the solution there to question 1. Moving on to question 2 now, where we've got 3 more one-step equations here. So let's begin with part A. We're asked to solve the following equations. So for the first part here, we've got 3 plus x equals 10. So 3 plus x equals 10. So again, all we're doing here is using inverse operations. So we want to solve for x here. So what I need to do is get rid of this 3 here. We don't write it, but in front of this 3 there is a plus. So this is positive 3. So using inverse operations here, what we need to do now is subtract 3 off both sides. So I've got 3 plus x and I subtract 3. 3 minus 3 would be 0. So we just get left with x there on its own. And on the right hand side here, 10 minus 3. Which in this case then would give us x equals 7. So that's the solution to A. Moving on to B now. We've got 6z equals 18. So again, let's just think about what we're doing with z here. So we're taking z and then we times it by 6. What's the opposite of timesing by 6? Well, that would be to divide by 6. Just using our inverse operations here, we divide both sides by 6. If I've got 6z and I divide that by 6, that would just leave me with z. And then we do 18 divided by 6 here. And in that case then, We evaluate the right hand side here, 18 divided by 6, so in other words, how many 6's go into 18, and that would give us 3. That's the solution to B. And then finally we move on to C here. We've got R minus 4 equals 3, so R minus 4 equals 3. So again, all we're doing here is just using inverse operations. So I just want to solve for R here. I need to get rid of this minus 4. The opposite of subtracting 4 here is to add 4 to both sides. We add 4 to both sides. So on the left hand side here, we get R minus 4 and then we add 4. So the minus 4 and the plus 4 there would just give us 0. We just get left with R. And on the right hand side here, we've got 3 plus 4. So 3 plus 4. And if we simplify that then, we get that R equals 7. Okay? And there we have it. So that's the solution to C. And that gives us the solution there to question 2. And finally then, if we take a look at the very last question here, question 3, again we've got 3 one-step equations to solve here. Let's begin with the first one, part A. We've got 12 equals 4A. So here we're looking to solve for A, and again this might look a little bit different because the variable that we're looking to solve for here on the right hand side, but don't forget this doesn't change anything, we still use inverse operations. So here we take A and then we times it by 4. So what's the opposite of timesing by 4? Well, that would be to divide by 4. So divide both sides here by 4. Divide both sides by 4 here. So we've got 12 divided by 4 here on the left hand side. Get 12 over 4. On the right hand side here we've got 4A divided by 4, and that would just leave us with A. Like so. So now we evaluate 12 divided by 4 here. So how many 4's go into 12? Well, that would be 3. In that case, then we get 3 is equal to A. But if we just write this here with our variable here on the left-hand side, we get A equals 3. Okay? And there we have it. And like always, you can double check the solution here. 4 times 3 would give us 12. We know that solution there is correct. We take a look at B now. We've got x plus 5 equals 3. So x plus 5 equals 3. So again, all we're doing here is just using inverse operations. We want to get rid of this plus 5 here on the left hand side. So to do that using inverse operations, we're now going to subtract 5 off both sides. So minus 5 off both sides here. On the left hand side then, we're just going to get left with x on its own. On the right hand side here we get 3 minus 5. So 3 minus 5 there. So if we evaluate this here, we get that x is equal to 3 minus 5. In other words, that's minus 5 plus 3 if you find that a bit easier. And in that case, we'd get minus 2. Okay, so we get x equals minus 2 there. And if we take a look here at the very last question here, part C, or I should say the very last part, so we've got z over 5. And that's equal to 9. So if we just think about what we're doing here with z, we take z and then we divide it by 5. What's the opposite of dividing by 5? Well, that would be to times by 5. We're going to times both sides here by 5. If I've got z over 5 and I times that by 5, that would just leave me with z. We get z on the left hand side, and on the right hand side here, we've got 9. So if we times that by 5, and then if we evaluate this here, so 9 times by 5 would give us 45 there. So z is equal to 45, and there we have it. So that's the solution to A, that's the solution to B, and that's the solution to C. And that gives us the solution there to question 3, and that brings the end of this video on exam revision for solving one-step equations. In the next video, we're going to take a look at properties of angles.